we're asked to write the dissociation reaction and to calculate the concentration of each ion. Sodium phosphate, soluble compound. When it dissolves, it's going to dissociate into 3 sodium plus ions and a phosphate ion. Okay, we are starting with 0.20 moles of sodium phosphate per liter of solution. And our dissociation reaction shows us that every mole of sodium phosphate is going to give us 3 moles of sodium ions. So now we see that the units of moles sodium phosphate will cancel, and we'll have moles of sodium ion per liter. And we do the associated math, 0.2 times 3, to see that we have 0.6 moles of sodium ion per liter of solution. Now we start at our moles of our solute per liter. However, every unit of sodium phosphate is only going to give us 1 mole of phosphate ions. We can see that from our stoichiometry. So now we see that our concentration of phosphate is 0.2 moles of phosphate ion per liter of solution. Similar process for sodium sulfate. First, a dissociation reaction. Here we see 2 units of sodium ion per unit of our compound and 1 unit of sulfate ion in solution. So 0.50 moles of our solute, which is sodium sulfate, per liter of solution, and every mole of sodium sulfate is going to give us 2 moles of sodium ion. So we have, our math indicates 0.90 moles of sodium ion per liter, because our units of moles of sodium sulfate cancel out. Here's the concentration of our solution. It's moles of our solute per liter. And in this case, every mole of our solute is going to give us 1 mole of sulfate ions. Let's write our dissociation reaction. We're going to get 2 sodium ions and a chlorate ion in solution for each unit of sodium chlorate. So we start with the concentration of our solution. And we're going to use our factor, our mole-to-mole factor. Every mole of our solute is going to release 2 moles of sodium ion. So we see a 0.40 mole of sodium ion per liter. Let's go for the other ion. Here's our initial solution. And every unit of our solute is going to give us 1 chlorate ion. Okay, our last example. Let's first do the dissociation reaction. Aluminum nitrate. Oops. We have 1 atom of aluminum 3 plus and 3 nitrate ions. So start with our solution. This is the moles of our solute. Per liter. And every mole of our solute is going to give us a mole of aluminum 3 plus ions. And finally, our remaining anion, we'll start with our initial solution, moles of our solute, and in this case, every mole of our solute is going to give us 3 moles of nitrate ions. So we do our math. And we see our solution contains 0.60 moles of nitrate ion per liter.